Hello and welcome to ICSE Grade 10 Mathematics, Chapter 6 Quadratic Equations Word Problems. I have actually selected just one question from one of the exercise, that is exercise 6D from Concise Selina. Question number 10. The question is slightly more, there are more number of words, that means it's a story type. And so usually when the length of the problem is very long, students find it difficult to understand. And so that is why I have selected this question. Myself, Simant Mure, a mathematics educator for last 26 years, and I have helped over 4,000 students with maths. Presentation is brought to you by Simanti Tutorials. Let's have a look at the question that I'm saying. This question is identical to the Concise Mathematics Selina publications from your textbook for ICSE Grade 10 Mathematics. So the question says, we have a passenger train that leaves city A at 5:30 p.m. and travels towards city B at a speed of y kilometer per hour. A superfast train leaves the same city A at 7 p.m., traveling on the same route at a speed of y plus 25 kilometer per hour. The distance between city A and city B is 975 kilometers. The superfast train arrives at city B 45 minutes earlier than the passenger train. We have to find the speed of each train. So, um, the question is quite long, and so I always advise students to in my class that irrespective of whether the question is long or short, always identify the data which is given to you. And I'm going to do the same thing. As I read, I'm going to try and put the data on the paper over here. So a passenger train leaves city A. I will denote TP as passenger train, leaves city A at 5:30 p.m. at a speed of y kilometer per hour. Then we have a super fast train. I denote that as T suffix S. Again, leaving city A towards the same city B at 7 p.m. with a speed of y plus 25 kilometers per hour. Now the distance between city A and city B is 975 kilometers. Kilometers. They have also said that the superfast train arrives at city B 45 minutes earlier. City B 45 minutes earlier. I will change this minutes into hours over here itself, and for that we divide by 60. It's 45. 15 times 3, 15 times 4, 3 on 4 is 0.75 hours. we are supposed to find the speed of each train. I have put all the data which is required now on the screen. Now we need to think of the formula. So what I understand from here is, they've given us speed, they've given us distance, also there is a time. So let me put the formula: speed equal to distance over time. That means time is equal to distance upon speed. Right? Okay. So with this, we have time as distance upon speed. So I'm going to use this formula and find the time uh, of journey for the passenger train. Total time taken by passenger train is distance is 975. Speed of passenger train is y. So that's 975 upon y hours. Let's apply the same formula and find the total time taken by the superfast train. So time taken by superfast train to reach B is 975 over y plus 25 hours. Now comes the most important and interesting part. I'm going to form an equation, and that is what students find it challenging. So please observe carefully. They have said that the superfast train leaves at 5:30, sorry, passenger train leaves at 5:30 p.m. And to this, I'm adding the total time taken by the passenger train. That was 975 over y. So we understand that if I add this much time to 5:30 p.m., we get arrival time. So this is the arrival time of passenger train. The superfast train leaves at 7 p.m. The total time taken by the superfast train is 975 upon y plus 25. I added this. So this is the arrival time of superfast train. To make an equation, we need to equate these two. So 530 plus 975 upon y is equal to 7 plus 975 upon y plus 25. I cannot equate them directly because the superfast train arrived 45 minutes earlier. So that means if I add that value which we found earlier, 0.75 hours, to the arrival time of superfast train, then only the arrival times for both the trains will be equal, right? So I added 0.75 to the arrival time of superfast train to get, or rather equate it with the arrival time of passenger train. Now 975 upon y minus 975 upon y plus 25. I took this term to the left hand side, is equal to 7 plus 0.75 minus 530. So understand that this is timings. These are the timings. So we need to convert 7 p.m. and 5:30 p.m. into hours. Okay. Now 975 upon y. I'm going to take 975 as a common factor. 1 upon y minus 1 upon y plus 25 equals 7 p.m. minus 5:30 p.m. is 1.5 hours, to which we are adding 0.75 hours. So that becomes equals to 2.25 hours. Okay. 7 minus 5:30. So this is 1.5 hour. 1 hour 30 minutes. 0.75 hours were added. This is half an hour. 30 minutes is half an hour. I'll write it this way. So to 1.5 hour, if you add half an hour, it becomes 2 hours. 0.25 above that, so that makes it 2.25 hours. Now cross multiply, or rather take LCM in the brackets. So we get y plus 25 minus y upon y into y plus 25 equals 2.25. The y gets cancelled. Now we are going to cross multiply. So 975 into 25. I will also take 2.25 to the other side, so it comes to the denominator, equals to y times y plus 25. Let's remove the decimal from the denominator now. So that's 975 into 25 times 100. If I multiply the denominator by 100 to remove the decimal, you need to multiply the numerator also by 100, right, to keep the balance. Open the brackets on the right hand side, which is y square plus 25y. 2.25 times 100 is 225. 25 times 9, 3 threes are 9, 3 twos are 6, 1 carried 15, 3 fives are 15. And so we have 325 times 100 as 32500 equals 3y square plus 75y. I took 3 to the other side and multiplied both the terms with 3. Now collect 32500 to the right hand side. So this becomes 3y square plus 75y minus 32,500 equals to 0. Now, factorizing this is going to be challenging because the numbers are very large. So, if you feel in a word problem that factorization is difficult, do not hesitate from using the formula. So, by formula, method, y is equal to negative 75. Let me write the formula first. Minus b plus minus square root of b square minus 4ac upon 2a. Now put the values. So b is 75. So that becomes minus 75 plus square root of 75 square minus 4 into a is 3 times minus 32,500. Let's make space. To make space, I need to erase everything. So 75 square minus 4 into 3 into minus 32,500. Yes, it fits. I also reduce the size of the font annotations, and that helped me to accommodate in the given space. Adjustment upon 2 into a. A is 3. So y is equal to minus 75 plus minus square root of. Now 75 square is when the number ends in 5, its last two digits are going to be 25 always. Consider the remaining digits excluding 5. In this case it's 7. The successive number of 7 is 8. Find product of 7 and 8. 56. So square of 75 is 5625. Minus into minus is plus. I cannot accommodate over here. So once again, adjustment. Let's move on to the next slide. Whew. So y is equal to negative 75 plus minus square root of 5625 plus what we had was 12 into 32500. I'm going to check it once again. 32500. That's correct. Now 12 times 5 is 60. I write 0 and carry 6. 12 2s are 24 plus 6 is 30. I write 0 and carry 3. 12 3s are 36 plus 3 is 39. And these two zeros were left. So I put these remaining two zeros. So this is 3,90,000 upon 6. So this becomes y is equal to minus 75 plus minus 3,95,625 upon 6. Now that's a huge number, and so we will have a way to find out square root of this. Now you can actually find square root by factorization method. I'm also going to do the same thing, but I may try to take larger numbers directly. We know square of 100 is 10,000. Do we know? Yes. Square of 100 is 10,000. Square of 200 is 40,000. So what we understand is, sorry, 100 is 10,000, 200 is 40,000. We need 3,95,000. Okay, so let me start with 25 first. So 25 ones are 25, 14 145, 25 fives are 125, 206, 25 eights are 200, 62, 25 twos are 50, 125, 25 fives are. Okay. Again, 25. 25 6 are 150, 82, 25 threes are 75, 3 carried 75, 25 threes are. Now, 3 times 211, and um, now 211 square root. We have 211. Now this seems to be a prime number. I'm going to do it this way. Y is equal to minus 75 plus minus square root of 25 into 25 into 633, the whole divided by 6. So minus 75 plus minus 25 square root of 633 upon 6. And now I'm going to use the square root tables to find square root of 633. Let me remove this part. So y is equal to minus 75 plus minus 25 into square root of. We can write 633 as 6.33 times 100 upon 6. So square root of 100 is 10, minus 75 plus minus 25 into 10 into square root of 6.33. Let's find out the value of 6.33. So 6.3 row and third column. So that is 2.516. So this is 2.516 upon 6. So this becomes minus 75 plus minus 25 into 25.16 upon 6. We can multiply 25 and 25.16. Let me show it to you how I would multiply. I will do that because I know table of 25. I'm going to select both these numbers. 25 times 6 is 150. I write 0, carry 15. 25 times 1 is 25, plus 15 is 40. Write 0, carry 4. 25 5s are 125, plus 4 is 129. Write 9, carry 12. 25 10 2s are 50. 50 plus 12 is 62. So this is 629.00. Okay, so this is going to be minus 75 plus minus 629 upon 6. So y is equal to minus 75 plus 629 upon 6, or y is equal to minus 75 minus 629 upon 6. We will not consider this since y is the velocity, y is the speed of the train, and speed cannot be negative, so not possible. I will not even bother to evaluate that. You can do that. 620 plus 70 is 690. 699 plus 5 is 704. Okay, 704 by 6, negative 704 by 6, so that is uh, 3 is a 6, 352.5, sorry, 352 by 3. Y is equal to 629 minus 75. 9 minus 5 is 4. 12 minus 7 is 5. 554 by 6. This is 2 2s are 4. 7s are 14. 7s are 14 upon 3. So 3 9s are 27. 3 2s are 6. 92 1 upon 3 kilometers per hour. So velocity or speed of the passenger train is 92 1 upon 3 kilometers per hour. And for the super fast train, it was 25 kilometers more. So 25 kilometers per hour more. So simply add 25 to 92. That is 117 integers 1 upon 3 kilometers per hour. Now, if you found this question interesting, if you found this question difficult and you understood, I would request you all to like the video and subscribe to my channel. Share it with someone who may find it useful. I'm sure this in this question, it was lengthy. I tried to help you identify how to put data on paper. I helped you to form the equations, and I also tried in this question where the factors are quite large. We can directly use the formula method, and we also solved how to find the square root from the square root table. Have a good day and take care.